Hi students, this is AJ sir. Let's study 9th standard ICSE Math, Chapter 22, Trigonometry, Exercise A. Also to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information. First, let's understand the definitions of the trigonometrical ratios. We have sine, cosine, in short we call it cos, tangent, which we call it as tan, and then we have their reciprocals. Now this is applicable only for right angle triangles. So in triangle ABC, if angle B is 90 degrees, then the angle of reference is, let's say, angle A, or it could be angle C, one of these. The angle of reference can't be angle B because that's 90 degrees. If we are talking about angle A, then AC is the hypotenuse, of course. Side AB is called the adjacent side, and side BC is called the opposite side because it's opposite to the angle. Whereas if we were talking about angle C, then AC would be hypotenuse once again, AB would be the opposite side, and BC would be called the adjacent side. Now these are the definitions. An easy way to remember it is Osha Chota. So if you want to find the sine, and remember these are ratios, they don't have any units. If you want to find the sine, then it's O upon H, that is the opposite upon the hypotenuse. If you want the cos, it is A upon H, that is adjacent upon hypotenuse. And if you want the tan, it is O upon A, that is opposite upon adjacent. So remember these three definitions. Sine is O, the opposite upon hypotenuse. Cos, or that is cosine, is A, that is adjacent upon hypotenuse. And tan, that is tangent, is opposite upon adjacent. This way we can find certain ratios. The remaining three ratios, that is cotan, also called cot, secant, which is in short called sec, and cosecant, which is called cosec, they are the respective reciprocals. Cot is a reciprocal of tan, sec is a reciprocal of cos, and cosec is a reciprocal of sine. Or you can remember it like this. Cot would be adjacent upon opposite, sec would be hypotenuse upon adjacent, and cosec would be hypotenuse upon opposite. When we'll do the numericals, the picture will be clearer. Right now, just remember this hint and the definition. What is the use of trigonometry? Well, it's very useful in engineering and in many other fields. It has practical applications. Imagine if you had a tower, a building, and you could see its shadow on the road. By just measuring the shadow's length and knowing the inclination of the sun in the sky, you could actually calculate how tall this building is with the help of trigonometry. But right now we are just studying the definitions of trigonometrical ratios and how to calculate things. Its practical applications will come much later. So hold your horses till then. Let's start with sum number 3. There are 6 subparts. The diagram is given. Okay. Now, first, Roman number 1, they want cos A. Now when they say cos A, this angle, clearly we have to consider triangle ABD. Let's call this D out here. So we'll have to draw the diagram. We can't consider triangle ABC because I don't see any right angle out here. Angle B is not 90 degrees. So just focus on triangle ABD to find cos of A. The best way to start is first find the missing side. Now in triangle ABD, I have AD, I have BD, but I don't have AB. So let's find it by Pythagoras theorem. Because it's 90 degrees, right? It has to be 90. Then only we can solve such sums. So Pythagoras theorem would be the central theme of this entire exercise. We'll be using it in every sum. And by now you would already know the Pythagorean triplets. For example, this is 3 and 4. So I'm sure you know that AB is 5. So if you don't show that, all the calculations and directly write AB as 5 by Pythagoras theorem, it's okay. In trigonometry, it's allowed. So that's what I did first. I found AB 5. No units here. No centimeter, no meter, because in the question they have not mentioned it. If they would have mentioned some unit, then we would have written the unit for AB. But in the final ratio answer, of course, there are no units. Similarly, even in triangle BDC, let me find DC by Pythagoras theorem because I know it will be required in the sum. So that's what I did first. I found CD as well, which came out to be root of 128. It's not a Pythagorean triplet, so I had to show all the steps for this. Then you do prime factorization of this. It'll be 2 into 2 into 2 into 2 into 2 into 2 into 2, out of which 3 2's come out. 3 pairs of 2's come out to give you 8, and 1 2 remains in the root under the umbrella. Now we can start with the sum. Roman number 1, cos A. If you remember Osha Chota, cos is adjacent upon hypotenuse, isn't it? A upon H. It's adjacent upon hypotenuse. So look at the diagram and tell me, for angle A, which is the adjacent side, it's AD. Not AB. AB is a hypotenuse. AD is the adjacent side. And opposite is BD. So the ratio will be AD upon BD. That's the definition. AD upon BD, which is 3 upon 5. Done. Can we reduce it further? No. That's the answer. So cos A is 3 upon 5. All the answers are always ratios. Next, cosec A. So try to recall the definition of cosec A. Cosec is the reciprocal of sine. That means it will be hypotenuse upon opposite. So first learn all the definitions perfectly. Then solving these sums will be so much faster and easier. So what is the hypotenuse? Look at the diagram. It's AB and upon opposite side is BD. So hypotenuse upon opposite, AB upon BD is 5 upon 4. Well, it's an improper fraction, so we have to convert it into a mixed fraction. That's compulsory. Roman number 3, they've asked us to find tan square minus sec square A. Well, let's find tan A first. What was the definition of tan A? It was OR. That is opposite upon adjacent. Opposite side for angle A is BD. Please focus only on triangle ABD for this. And adjacent was AD. So O upon A is BD upon AD. You have to mention this. BD upon AD upon 4 upon 3. That is 1 upon 3. Sec A. What was the formula for sec A? Think about it. It was the reciprocal of cos. So that's hypotenuse upon adjacent. All the reciprocals are mentioned for exercise B. So if you want to reference this, you just pick it. So sec A would be AB upon AD, which is 5 upon 3 or 1 2 upon 3. Here it was not important to convert it into the mixed fraction because ultimately they want tan square a minus sec square a. So we substitute the values, we square them, denominator is same, and finally we get the answer as minus 1. Please close your window, I can hear a bird. Now interestingly, tan square a minus sec square a in any right angled triangle with any values will always be minus 1. In fact, sec square a minus tan square a is equal to 1 is one of the identities which we would learn in the future. Now sin C. For sin C, we'll have to focus on the other triangle BDC, because angle C belongs to that right angle triangle. So for angle C, BC is the hypotenuse, BD is the opposite side, and DC is the adjacent side. Keep these things in mind. Sine formula is O, opposite upon hypotenuse, O upon H. That is BD upon BC, which is a 4 upon 12, which is 1 upon 3. We have to reduce it if we can. Sec C is the reciprocal of cos. That's hypotenuse upon adjacent, H upon A. That is BC upon DC, that is 12 upon 8 root 2, cut, we get 3 upon 2 root 2, but we can't have denominator with a surd or root sign, so we'll have to rationalize the denominator into root 2, that becomes 2 into 2, 4, and this becomes 3 root 2 upon 4. That's the final answer. Cot C. Sin C is 1 upon 3, that we already calculated here. So now they want cot square C minus 1 upon sin square C. So substitute the values, square them, denominator goes to numerator, and finally you'll get the answer as minus 1. Now the fifth sum. Given sin A is equal to 3 upon 5, find tan A and cos A. So how will we solve the fifth sum? The third sum, we saw how we substitute the values. But here a ratio is given in the fifth sum. So first we have to draw a triangle. So we assume that there is a triangle ABC with right angle at B. It couldn't be A because they have asked sin A. So A has to be the angle which is being referred, which cannot be the 90-degree angle. We could have written A here and C here as well. That's fine. If they say sin A is 3 upon 5, that's a ratio. And what is the definition of sine? It's O upon H, opposite upon hypotenuse. That is BC upon AC, that is 3 upon 5. So we'll assume BC to be 3x and AC to be 5x. So that's what I've written here. These are our assumptions. It's necessary to write x. We can't just say AC is 5 and BC is 3. That's not true. There could be multiples of them as well. Although if you do that, you'll get the right answers always. But that's not the right way to do math. Now if this is 5x and 3x, using Pythagoras theorem we can find AB. So we solve it and we get the answer as 4x. These steps are not necessary because you know the Pythagorean triplet. So after adding 3x and 5x, we could simply say that therefore AB is equal to 4x by Pythagoras theorem. Now that we got all three sides, we are ready to solve anything they've asked us to. They've asked us to find tan. The tan is O upon A, opposite upon adjacent. That's opposite of A is BC and adjacent is AB, not the hypotenuse. So that's 3x upon 4x, x cut, and that is 3 upon 4. So now you see in the final answers x won't appear anyway because of the ratio. Cos is a upon h, adjacent upon hypotenuse. So we get the answer is 4 upon 5. Similarly, let's do the 7th sum. So they've given the value of cos a, 5 upon 13, and they've asked us to find certain ratios. So first of all, we draw a triangle. We assume 90 degrees at B. Cos A. So here I've taken A as this, and cos is adjacent upon hypotenuse. That is AB upon AC is 5 upon 13. So assume AB to be 5x and hypotenuse to be 13x. By Pythagoras theorem, we know that CB will be 12x. Now that we know all three sides, we can find the ratios. Find sine A, cot A, tan A, and then this is what they have asked. So substitute all these values out here, and it's a normal algebra sum. Do the LCM, and when division becomes multiplication, we have to write the reciprocal of this out here. Reduce it as much as possible. If not, then leave it as it is, and this is your final answer. Notice how there is no x in the ratios. It was just in the diagram, because here BC upon AC is 12, x upon 13x, x and x cut. No need to show that step. When if you do, it's okay. Now the 9th sum is very similar. Again, tan's value is given 4 upon 3, and they've asked us to find something. So after doing 7.2 by a similar method, and notice how we have to write a mixed fraction. In the 9th sum we'll have to draw a diagram. Notice that tan's formula is OA, O upon A, that is opposite upon adjacent. Be very careful about these terms, because it is such an easy and scoring chapter. The only problem is silly mistakes which might be made by you, so be attentive. By Pythagoras theorem, find AC, which is 5x of course, and now we can find the other ratios. We can find cosec, cot, sec with their respective definitions. Note there is no x in the final answer. Substitute it in here, find the LCM, and get the final answer. It will be a mixed fraction. Next, the 11th sum. Again, cos A 0.6, that is 6 upon 10, that is 3 upon 5. So it is like any other sum. They've given a ratio of 3 upon 5, and cos is adjacent upon hypotenuse. So draw a triangle. B is 90 degrees, A is not 90 degrees. So this will be the opposite. This is the adjacent, and this is the hypotenuse. Assume these as 3x and 5x. By Pythagoras theorem, this is 4x. So get the value of sine, get the value of tan, cosec, sec, cot, using their definitions, and mixed fractions if required. 13th sum. Now here sine theta is P upon Q. This is quite a challenging sum. So we'll assume a triangle ABC and 90 degrees at B. They said sine theta is P upon Q. So I'm assuming angle A as theta here. So we have to write that. So if sine theta is P upon Q, and we know that sine is O upon H, so we can assume the opposite side to be Px, where x is the multiple, and the hypotenuse as Qx. If your school teacher teaches you or allows you to solve without x in any of the sums, then I'm okay with that. Ultimately, your school teacher will check your papers. But in ICSE board exams, it's not allowed. So using Pythagoras theorem, we'll find the value of AB now. It is not a Pythagorean triplet obviously, so we'll have to show all the working. X square can be taken out common, and the square root of that is x, so that comes out of the umbrella, but this remains inside. So this is the value of AB. So let's find cos theta. Cos is adjacent upon hypotenuse. X and x gets cut, of course. In the final answer, we can't have x. So this is the answer of cos theta. Sin theta we already knew. And just add the two values. Denominator is common. Great. We can't do anything more. This is the final answer. Now the 14th sum, that is a very important sum. Here they've given cos A and sin B, but note that they have mentioned that angles A and B are from different triangles, not from the same triangle. Even if we would have assumed it to be from the same triangle, it would have been totally wrong, because it's not possible. These values don't match, they are not compatible with each other. So we'll just consider these to be two different sums, cos A in one triangle and sin B in another triangle. Cos A is 1 upon 2. So let's assume the triangle ABC, B is 90 degrees. Cos is adjacent upon hypotenuse. So this is 1x and this is 2x. Using Pythagoras theorem, find BC, which will be root 3x. Yeah, show the steps. It's not a Pythagorean triplet. Now that we know the three sides, I can find tan A, because in the question they've asked for tan A. Tan is opposite upon adjacent. Opposite is root 3x and adjacent is x. X cut, so the answer is root 3. Fine, so we got tan A. What else is asked in the question? Tan B is asked. But now we have to draw a completely new triangle, ABC, and we have to find tan B, right? So we can't assume B to be 90 degrees because the angle under reference is B. So it has to be some other angle. So let's assume C to be 90 degrees here. In that case, if they have said that sine B is 1 upon root 2 and sine is opposite upon hypotenuse, that means AC is the opposite side for angle B and hypotenuse is AB. So we'll assume this to be 1x and this as root 2x. So by Pythagoras theorem, we can find BC, which comes out to be x. And now we can find tan B in this new triangle, which is 1, interestingly. And then this is what they have asked. Substitute all the values. And you'll have to rationalize the denominator here by multiplying with its conjugate. A plus B into A minus B is A square minus B square. Look at the numerators, they are same. So that will become A minus B the whole squared. That is A square plus B square minus 2AB in the numerator. And the denominator, well, we got rid of the umbrella, so it is now rationalized in the denominator. Notice that 2 can be taken out common, which is good because now 2 and 2 get cancelled and this is the final answer. A pretty long and important sum. Now, few things to remember here is, yes, it's a different triangle, so we could have named it differently, like P, B, Q. That's possible. It wouldn't make a difference, but also here we used X as a common multiple. You could have used Z or Y as a common multiple here. But again, I'm treating it like a very separate case, so it's okay. Because anyway, in the final answer, X and Y won't be included. So there won't be any confusion even if you use X again. Also, we could have solved the entire sum in just 3-4 steps if we had the knowledge about some values of trigonometrical ratios, which would be taught in future chapters. For example, the moment they say cos A is half, then we know that it has to be 60 degrees. Angle A is 60 degrees. And tan of 60 is root 3. So see, that's what we got, root 3 as the answer. Similarly, when they say sine is 1 upon root 2, sine B, that means that angle is 45 degrees. And tan of 45 is 1. So, see, tan is 1. So, instead of calculating so much, when you will learn this table in the future, and there is a trick to remember this table, you would know the values even without solving anything. Mentally, you could know all the values. But that's in the future. Let's stick to the basics right now. You all are amateurs, trigonometry is new for you. So, very soon you'll become the master of trigonometry. Now the 15th sum, 5 cot theta is equal to 12. So send 5 down so that it looks like a ratio and it becomes a very ordinary sum. Once you get the ratio, and cot is how much? What is the formula for cot? It's AO. that is A upon O, adjacent upon opposite. So draw a triangle, let this be the theta, this is 90 of course. So adjacent is 12x and opposite is 5x. Pythagoras theorem, AC is 13x, so we can find cosec theta, sec theta, and we can add them to get the final answer. This is not an identity. This is not going to be the answer for every sum or every triangle. There are some identities which you'll study in some future chapter. Identities means equations. And finally the 18th sum, which is again important, although very easy. Sec A is given root 2 upon 1. So using that ratio, draw a triangle. Sec means it's a reciprocal of cos. So that would become h upon A, hypotenuse upon adjacent. So the hypotenuse will be root 2x and adjacent will be x. So we'll have to use Pythagoras theorem here. And I know that if this is 1 and this is root 2, this also has to be 1. So 1x. But you can show the steps. And now we can find what is asked. We'll find cos A, sin A. Notice how it was actually 1x upon root 2x and x got cancelled. That is why we got this ratio. Find sin A, find tan A. Now this is what they want us to calculate. So substitute all the values. This is a normal algebra sum. Square them. BODMAS rule. LCM. Division becomes multiplication with the reciprocal. And this is the final answer. So what is the use of such sums in engineering? This is not important, right? Think of it as a riddle to sharpen your mind. The more you practice, the more intelligent you are becoming. And definitely spending time in solving math is much better for your brain rather than watching IPL every day.